I think we're ready to get started. First, Ceph Days. How many of you have been to a Ceph Day before? By show of hands. 1, 2, wow, not a whole lot of people have been to Ceph Days. Okay, that's cool. Well, welcome. Thank you for coming. I appreciate you being here with us today. We've done a bunch of Ceph Days. This is the last one of our current program. We're getting ready to announce some new dates, but we haven't done it yet. But first, I'll just describe a little bit about what Ceph Days are. We've been doing these for a couple years now, all over the world, starting with the first one in Amsterdam. We've been on a lot of different continents with these. Ceph Days are events where members of the Ceph development community and members of the Ceph user community and other related companies can get together and talk about things. We solicit content from the community, so people who are developers on Ceph or who are building things with Ceph are invited to come speak, and we're all here. So the point of the day is to meet other people who are using Ceph, to trade stories, to learn how people are deploying it in production and what their experience is. At the end of the day, we're going to have a Q&A where all of the speakers from the day will come up here and we can ask them questions and discuss kind of the topics of the day. But throughout the day, if you have questions, yell them out. We'll keep it interactive and interesting in here. So there have been a lot of Ceph Days. The one that isn't on this list is Ceph Day Amsterdam, which actually happened in 2012, and it was our very first one. But we've been to New York twice. We've been to the Bay Area twice. This is our second time in London. We've been to Germany, Boston, and Paris. And like I said, this is our last Ceph Day on the current schedule. So keep your eyes peeled for other dates in the future. But this is where we've been so far. So we've been to a lot of places and had a lot of really good Ceph Days. Really quickly, a show of hands. How many people in this room have downloaded Ceph bits and started reading docs about Ceph? Okay, that's most of us. Great, 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 great. Okay, keep your hands up. Keep your hands up if you got Ceph working on a VM. Right, you actually got it deployed on a VM. Oh, still have some hands up. Wow, that's okay. Still, I see hands coming up and down. They're like, did I? I don't know. It said it was working. Okay, keep your hands up if you installed it on real hardware, like actual real hardware. Okay, good. Now keep them up if you deployed it in production. All right, 1, 2, 3, 4. We got some hands in here. Very good. Okay, that was really cool. I like seeing that. Another one. Raise your hand if you use Ceph to store objects. Right, we've got a couple of hands. All right, how about blocks, like block devices, virtual machine images, that sort of thing? Okay, and if your primary purpose in using Ceph is for files and directories, like using CEPHES. 1, the living dangerously, right? All right, very good. And then I have one final one before we move on. If you're using RHEL CentOS packages, put your hands up. All right, a few, actually quite a bit. Ubuntu Debian packages. There we go, a bunch. SUSE packages, not so much. What else? Raise your hands if you're using something else, something that is not one of these three. Okay, cool. So that's a pretty good split. Wow, we have a lot of different uses in this room. That's pretty cool. Going over the agenda, there's one change I need to tell you about. Vito, who has this slot at 11:15, is still in the air somewhere between Amsterdam and here, and he'll get here later than 11:15, unfortunately. So John Spray has volunteered to swap spots with Vito. So John will be on at 11:15. Otherwise, the schedule is pretty much the same. And it starts with me doing this welcome and kickoff that you're watching me do now. After this, I have another 45 minutes where I'm going to talk about, sort of what's going on in the Ceph ecosystem, what's new, what's coming up next. I might not take that much time. Then we have Paul from Dell coming up to talk about best practices for Ceph, storage as a service implementations. Vito, again, is a little bit later, but his is about deploying Ceph in the wild. He's deployed Ceph at his service provider in the Netherlands. Then we have a really quick lunch break. Well, actually, it's not quick. It's like an hour. And then we have Richard from Mellanox joining us on stage. Following Richard, we have Florian from Histexo talking about performance demystified. Performance is a big topic for Ceph today, a really big topic for Ceph today, so that should be a pretty interactive session. Then we have an afternoon break. After the afternoon break, Zoltan from IBM is going to talk about how they engage with Ceph. And then John, his talk on CEPHES development, of course, is swapped, but he'll be speaking about CEPHES in the morning. And then at 4:30, we break for our QA and roundtable, where all the speakers come up and we can, you know, cover anything that didn't get covered. And then after that, we drink. Sound like a day? Sound like a good day? All right, wonderful. I'd like to take this opportunity to thank our sponsors. Ceph Days are, we don't make any money on Ceph Days. We try to break even. And so these don't happen without our sponsors. You know, venues cost money. So Red Hat, we'd like to thank Red Hat for helping us put on this event. And also Dell. Thank you very much, Dell, for helping us put on this event. So thank you so much for both of our wonderful sponsors. And with that, welcome. Again, thank you for being here. We really appreciate you joining us. And that's, okay, so that goes from one agenda item to the next. We've already finished that first agenda item, so yay, one down. This is a Ceph ecosystem overview that I'd like to give here. And I'll start by telling the story so far. How many people know what year Ceph started as an open source project? Anybody know?
About 10 years old?
It's about 10 years old, yeah. Actually, at OSCON in the Bay Area, a couple months ago, we celebrated Ceph's 10th birthday. So, you know, 10 years of an open source project, almost a production-ready file system. Almost. It's getting there. But yeah, we're about 10 years old. So I'll tell the story so far, kind of where it came from and why it existed and why it started and how it began. I'll talk about what's new, the things that have happened kind of recently, what the future might hold for us, and then some status on some programs that we run in the ecosystem. So first, the story so far. This is the number of distinct authors in a month period since the beginning of the project in 2004. So obviously the project is gaining some traction over time. When Inktank launched right about there, and you know, a lot of money was poured into the Ceph project because it was a company around it, and a lot of people started joining. But it's got this nice growth, and it's been really exciting. But it had this long period from 2004 to 2010 where a lot of the really hard work got done, and it was done by a very small group of core developers. And that's the period. It's really broken up into two periods that. Sage, the founder of the project, sort of describes as these different phases. And the first was the research phase, from the beginning of the project to maybe early mid-2007. This is characterized by the project. It was originally created as at UC Santa Cruz under a Department of Energy grant. So the United States Department of Energy wanted to figure out how to get a distributed file system that had scalable metadata. Because at the time they were using Lustre and it had some challenges with that. And so they wanted to invest in that kind of research. So that was how Ceph actually started, which is the real funny part, that Ceph started as a distributed file system and then object and block matured before the file system did, which is kind of an interesting thing that happened. But originally it was for a scalable, reliable, high performance distributed file system was what Ceph was built for. So these early research years were very formative. From 2004 to about 2006, it wasn't released as open source. It got released as open source in 2006 on SourceForge, and that was when Sage finished his work at UC Santa Cruz. And roughly in mid-2007 is when Sage took Ceph back to the company he had worked at before he went to college, DreamHost, and they continued to invest in Ceph, which is something that not a lot of college projects have. That they don't have that benefit, that you can go to college, you can work on this really interesting research, and then you can take it back to a company who continues to pay for it. It's really cool. So, I mean, yay, big round of applause for DreamHost. Thank you for keeping the project going for like 5 or 6 years. It made all the difference in the world, and we owe them forever. This was pure development. There were no deliverables during this phase. Imagine that. And DreamHost puts 5 developers on this and says, you know, whatever, just do what you want, right? Build this system you want to build. Not many technologies have a good 5 years of development where there aren't any deliverables. So that was really cool. It was an early growing community at the time. This is when we started to see people contribute Samba and Ganesha plugins, Rados block device, which is the way how you store virtual disks in Rados, originally came as a community patch during this period. This also saw the emergence of the Rados gateway, the object interface at that time, and the Linux kernel modules all happened during this incubation period. And towards the end of this incubation period, what was happening was that DreamHost started to realize they had something because other companies were starting to ask DreamHost if they could buy support for it. And these are DreamHost competitors, largely, who were saying, we want to run this. And it became a little bit strange, and it became very obvious that there needed to be a company that that took care of this project and continued to drive it forward. And so this is what I described as the age of Inktank, which was a little window in time, actually. As it turns out, that was a window in time. This is characterized by more stable releases. So you can see that the author count is climbing up gradually, or actually more than gradually. The releases became more stable. Documentation started to exist for the first time. This is when John Wilkins started to write docs, and he was the doc writer working at Inktank, and he would just read .h files and write docs. It was amazing. And so this is the period where all the documentation started to come into existence. We started seeing growing adoption, more deployments. We started to see the very first hardware companies talking about building appliances with Ceph and that sort of thing. And we also began to support multiple platforms, you know, Red Hat, Ubuntu, SUSE. And this is also when we started to grapple with these issues of, okay, so if there's Ceph, this is Ceph brand, then there's this Inktank brand, now there's Inktank Ceph Enterprise. We have these three brands that are almost the same thing, and we have to figure out how to differentiate. So we started to tackle some of these difficult marketing challenges of having an open source distributed storage platform. So that was sort of the age of Inktank. And what Inktank was trying to accomplish was essentially this. If you look at the left-hand side of this, that's how traditional proprietary storage works. You have proprietary hardware, which is really just computers and disks. It's nothing really all that special. It's processors and disks and standard hardware, but it's proprietary. And on top of that, there's some software and then some support and maintenance that you buy. And this is what you get from standard traditional proprietary vendors. And it's really, really big business, billions and billions and billions of dollars. What we think it should be instead is everyday hardware. Basic computers and disks. You know, you buy whatever disks you need, whatever computers you need. On top of that, you deploy open source software, and then you buy enterprise products and services if you need them. This is what we think it should be like for the storage industry. And this may ring some bells because this is exactly what happened with Linux and Unix. It used to be that in order to run Unix, you had to buy, you know, a Spark or something like that, or, you know, run Minix or whatever. But it used to be that it was a proprietary ecosystem, and Linux came out, and people chose to use commodity hardware instead of proprietary hardware for their Unixes. And so we're trying essentially to do to storage what Linux did to servers. And that's why it made a lot of sense for Red Hat to buy Inktank and become the sort of principal sponsor of the Ceph project. So this happened a couple of months ago. Inktank got purchased by Red Hat, and we think it makes a lot of sense because Red Hat can do what a startup could not do. And by that I mean lots of testing, lots of builds, lots of release management, the production hardening that it's hard for a startup to do, Red Hat does. That's what they do. So it made a lot of sense. And anyway, that's where we find ourselves today. That's the story so far of Ceph. So what's new? I think that probably I'll start with FIREFLY. So we name each of the releases in Ceph after different types of cephalopods. So we started with Argonaut, Bobtail, Cuttlefish, Dumpling, Emperor, and Firefly, which are all different types of squids or cephalopods or something. We're not marine biologists. We go to Wikipedia and we find one that starts with the right letter. I don't know what these things are, but you know, Firefly was then A, B, C, D, E, F. It was the release after E, and Giant is coming next, and then Hammer. And I don't know what I is, but I know that Z is going to be Zoidberg. So Firefly was released on May 7th, 2014. It was the first major named release of Ceph that was late. And it was late because there was a lot of stuff in it, and it took a lot of testing. It was also late because that was when we were getting bought, and that tends to distract you. So this was based on Ceph 0.80.x. So Firefly is the 0.80 release, and then all of the point releases of Firefly are 0.80, 0.1, 0.2, 0.3. The big features in Firefly were cache tiering pools, erasure-coded pools, and RGW user quotas. I'll go into a bit of detail about cache tiering pools and erasure-coded pools, but these are big. These are really big features for Ceph, and I think that something an interesting thing is that erasure-coded pools were probably the first major feature since the launch of Inktank that was primarily driven outside of the Inktank engineering organization. Erasure-coded storage backend, it was something that was requested, designed, architected, and largely implemented by people who did not work at Inktank and did not work at Red Hat. Many of those people have subsequently been hired by Red Hat. That's kind of how it goes. But I think that it was a really good, healthy sign of a community that that the Inktank folks weren't the only ones driving this project forward. So it was really good. Erasure-coded pools. How many are familiar with erasure coding? Okay, most of us. I'll give a bit of background just for those who aren't. Typically, in a standard backing pool for Ceph, it replicates each object. This is what's on the left. So, hey, let me back up. You have to establish durability some way. When you put an object into Ceph, you have to make sure that if that server goes away, that object still is around. So the typical way that it happens, on the left here, is you put an object into a pool, and it will make replicas of that object. So, if you set your replica level to 3, which is a sensible default, it'll make 3 copies of that object, and if one goes away, you have the other 2. This is super durable because you have 3 of everything, or 2 of everything, or 10 of everything, whatever you set it to. But it takes a lot more space. On the flip side, recovery is quick. If you lose one of those objects, you don't have to rebuild it, you just go get the other copy. An erasure-coded pool works differently. It takes that object and it splits it up into a bunch of chunks and then creates parity chunks in addition, such that in this one, for example, it splits it up into 4 pieces with 2 parity bits, and you can lose a certain number of these chunks and recreate them, right? So instead of making full copies of every object, it's using parity bits to sort of allow you to rebuild the object with just a few of the remaining pieces. So the benefit here is that you get durability that's not as high as a replicated storage backend, but it's cost effective. Actually, it's just as durable, but you have to actually calculate that object if you want to recover. So recovery is a little bit more expensive. The net of it is, if money is no object, you can have a replicated pool for everything, but if you need to put more stuff in less space, erasure-coded pools allow you to do that. Big feature in Ceph FIREFLY. The next thing that sort of was in Ceph FIREFLY was cache tiering. This allows you to have multiple pools in the same cluster, but one pool that acts as a cache for another pool is essentially all it is. You're designating that one pool is acting as a cache for another pool. And what you would do here is, for example, you'd have this backing pool that could be a replicated pool or even an erasure-coded pool, and you would have a cache pool sitting in front of it that has got, it's on solid state or something super fast, and it's much smaller, and it acts as a cache for the backing pool, which allows you to have cheap storage and expensive storage in the same cluster and do hot to cold data management between the two. Right, so the idea here is that, of course, this erasure-coded pool, you can set it up to be, 4 plus 2 or 8 plus whatever, or you can specify exactly what kind of economy you want in your backing pool and exactly what kind of performance you want in your caching pool, and they work together to do this multi-temperature data management. Big feature in Ceph, again, and it works with the erasure-coded pools to accomplish to make it really effective for cold storage. If you need to put a lot of stuff and you don't want to spend a lot of money to store it, then these features help out a lot with that. And of course, it can also be run in a read-only mode. So that's kind of what was really big for us in FIREFLY. That was the last major release of Ceph. That's where we've gotten to today. So what's next? It's of course hard to say. There's a lot of activity going on, but this is sort of how we see the storage market today. And we split it into 4 quadrants. The x-axis here goes between capacity and performance. So towards the left, capacity is more of a focus. Towards the right, performance is more of a focus. And then on the y-axis, towards the bottom is more traditional use cases that would require, for example, legacy protocols and that sort of thing. And towards the top is more next generation greenfield use cases. So Inktank Ceph Enterprise, and Ceph really, focuses on the upper left quadrant of this. Things that are focused on capacity, not performance, and things that are focused on next-gen use cases, not legacy use cases. And that's things like cold storage, storage as a service. OpenStack is definitely up there. Sync and share is there, but a little bit more towards traditional because you need some legacy protocol support to do that. So this is how we see the storage industry. We're definitely not here. We're definitely not down in the lower right quadrant. There's a lot that needs to happen before we're there. So the first major theme for the future work into Ceph is optimization. We want to go further to the right. So from the capacity-focused workflows to the performance-focused workflows. And this means, OSD optimization for SSDs. We're doing some messenger optimizations for more high throughput. We've got increased work going on into our multi-threading for high IOPS workloads. This is the work that we're doing to make Ceph perform better on a variety of hardware. And it's super important. It helps us go further to the right. At the same time, we would like to start moving a little bit south on this quadrant as well by integrating with existing systems like Kerberos, Active Directory, LDAP, providing iSCSI endpoints, and that sort of thing. That gets us more into traditional use cases. Then, of course, and this applies to everything, we need to simplify the installation and management of Ceph. Right now, if you were to take Ceph and give it to a traditional storage admin, they would run screaming because they're not used to dealing with distributed software. We need to make Ceph a little bit easier to deal with so that it's complicated software right now, and it has a lot of tunables and a lot of levers that you can pull and a lot of dials you can twiddle, and it's difficult to deploy. So better installation technology, the ability to manage Crush through Calamari, the user interface, and some parity between the CLI and the REST API. There's a REST API for management of Ceph, and there's a CLI, and right now they don't have parity, and they really should. So that's sort of the third thing is simplify, and then this, we hope, expands us into these use cases. Database as a service there on the right with Trove, compliance activities with the traditional, sort of more traditional activities. If you expose iSCSI endpoints, you can do some of that business. And then some real selected use cases for VMware based on the iSCSI endpoint. So this is where we hope to get to. And then the next version of Ceph is called Giant, based on the Giant Squid. It's real close to being released. The tree was frozen on September 9th. There have been two kind of RCs, 0.85. It wasn't really an RC, but it was the preceding release. That included some groundwork for RDMA support, which is really exciting. Some of the improved SSD performance went into this as well. We're deploying a CivicWeb-based RGW front end. So right now, if you want to deploy Ceph's object interface, you need to stand it up behind Apache. This allows you to use an embedded web server instead, which is a little simpler. It also has a new OSD blocked by command. So if you have an OSD that's wedged on something, you can find out what is wedging it, like what it's waiting on, which is good. 0.86 was released on October 7th. This was the Giant release candidate. It has a new OSD debugging tool, which is kind of interesting. I don't know a whole lot about it, but maybe John does, if you want to ask him. It also introduces local repair codes for the first time, which is erasure codes that are it's additional locality around erasure codes, so that if you have to rebuild an object, you can use local codes in addition to the erasure codes that are throughout. That's also something that maybe in the Q&A, if somebody wants to ask how that works, that would be great, because I don't know. There's a bit of a locking refactor on Liberatos. So again, this is a performance thing to make sure that it's releasing locks properly. Then there's some metadata server and monitor improvements that are going into Giant as well. So again, on the performance kick. Another couple of features that I'd like to mention here on RBD. Client-side caching. So if you're using Ceph's virtual block device, there was an option to have the client do caching for that block device, and it wasn't turned on by default. And that doesn't make any sense. So now it's turned on by default, and there are some options that allow it to be right-through cache until it's flushed, and some more sophistication around the client-side cache in RBD. And also there's support now for the Eucalyptus Cloud Stack in RBD. And then RGW, of course, there's this standalone CivicWeb front end, which is sort of an embedded C++ web server that allows you to not need Apache, which it simplifies packaging a whole lot and that sort of thing. And then CEPHES. CEPHES is not production ready. And every time I get on stage, I tell people this to make sure. People are using it in production, it's not production ready. So this is a complicated question. Anyway, there's been lots of activity on CEPHES. About a third of the core team at Red Hat that works on Ceph is working on CEPHES, which is pretty cool. There's been a lot of outside commits. A lot of the outside commits that have come in through Ceph have been on CEPHES. There's a lot of demand for people. People want CEPHES. We've started dogfooding CEPHES internally for our QA infrastructure, which is pretty cool. It's feature complete. It just needs to be tested. We very much want you to use it, not in production, and tell us how it works. What it needs now is usage. What it needs now is massive, massive, massive testing, but usage will do. So that's something that we really would like. And again, not supported versus not ready is definitely a question. We understand that this is, if this was WordPress, it would have been released ages ago, but it's a file system, and it needs to be stable. So we're not yet ready to say that it's production ready. People are running it in production, so really, your mileage may vary. It's at the stage now where we need to get people using it to understand what kinds of edge cases are problematic, because testing is only going to do so much. So we really need help from the community on CEPHES. And then I'll close here with a bit of an ecosystem update. Well, we got acquired, and that was weird, but very cool at the same time. Really, it was business as usual for Inktank and our customers. They told us, do what you're doing, which was cool. However, just as a result of being close to the people at Red Hat, we're increasing our support for RHEL, Fedora, and CentOS, and trying to become better integrated with those teams, so that there's so that the experience on those operating systems is good. I don't know if everybody's familiar, but at Inktank, Ubuntu was our primary platform of choice for the first couple of years at Inktank. We were very closely tied with Canonical and that sort of thing. So we have some catching up to do on RHEL, Fedora, and CentOS, and we're going to do that very quickly, of course, now that we sit across the hall from them. So this also started to bring up Ceph versus Gluster. People are saying, well, wait a second, Ceph's a unified storage platform, Gluster's a unified storage platform. Aren't these two sort of overlapping? But I think that's a false dichotomy. I think that there are definite use cases that are appropriate for Gluster and definite use cases that are appropriate for Ceph. And I think that I think that's kind of a false dilemma. I think it really depends on what you're using it for. And I think that both projects have something to offer the software-defined storage industry. So we've been spending a lot of time internally trying to make sure people don't see this as an either-or, because it really truly isn't, any more than Apache and Nginx is an either-or. It might be for a particular deployment, but certainly not in the community is it an either-or. And we're also hiring and growing. So if you know somebody who loves working on file systems, send them our way. We're always looking for people. So that's kind of what it's been like for us being acquired by Red Hat. It's been very interesting. It's been a lot of fun. There's a ton of potential to get stuff done. I'd also like to talk a bit about our Ceph Developer Summits. This is something that we do quarterly. I want to make sure everybody knows that these exist. If you think Ceph should have a feature that it does not have, here's the process. You go to the Ceph wiki, you fill out a Ceph blueprint that's a half a page on what you want to build. If you submit a Ceph blueprint for a particular Ceph Developer Summit, you'll get a session at the summit. And the summit is essentially a single-track summit where we spend 15 to 30, usually 30 minutes, talking about each of these topics, where the entire development team will discuss the topic. They'll figure out the best way to move forward and the right implementation path. And it's essentially a sync-up for the entire Ceph community. It's 100% virtual. You don't have to fly anywhere. You do it from your computer. And this is the way that people get features into Ceph, is by submitting blueprints and coming to Ceph Developer Summit, and they're open to anybody. So keep your eyes peeled. CDS Hammer is coming out soon, October 28th and 29th. It might actually be 28th, 29th, and 30th, because Patrick, our community manager, is telling me that we got mega blueprints this time, and we might have too many for 2 days, which is super cool. So Ceph Developer Summits are really casual, but they're the time to sync up with the Ceph developer community. I'd also like to cover metrics a little bit. We've always felt very strongly about being public about our metrics. Well, You can go to GitHub and look at all the, it's all public data anyway, but we wanted to make sure that we had a dashboard people could go to figure out how active the project is. So we went to a company called Bitergia, that's their logo there, and what Bitergia does is they build dashboards for open source projects that let you look at how many developers and how many tickets are opened and closed and how many mailing list messages are posted and that sort of thing. They continue to evolve their platform over time. It's all open source. You can go steal their stuff and use it. They want you to. And we benefit from improvements to their core platform. Whenever they make an improvement for another open source project, we get that improvement. So it's a really fantastic service. Currently we have source code, our issues, our IRC chat logs in there, and our mailing lists. We'll have downloads soon. And downloads is a tricky one because what does a download mean for Ceph? It's such a bizarre number, but it means something when you look at it as a trend. So these are the current metrics. If you go to metrics.ceph.com, you can see exactly this and dial through and look at exactly what's going on. We had our highest month for commits ever a couple of months ago by a lot, like by a ton. I mean, it had been growing as Inktank became, started hiring developers, but I've never seen it that high before. There was a lot going on. We've had similarly high metrics in all of these other places. I mean, so far, projects from the beginning of the project to today, there have been 349 developers on the Ceph project. 12 of them are core and work on it all the time. 19 are regular and come by every so often. We see more people participating in tickets. There have been 56 people fixing bugs in the bug system and 457 people reporting bugs, which is nice. And as far as discussion, there have been about 2,000 people in the mailing list over time. So the community is growing steadily, but I just wanted to make sure everybody knows you can go to metrics.ceph.com and see any of this anytime that you want if you're curious. And finally, a little bit of information about Google Summer of Code. We participated in Google Summer of Code for the first time this year. How many people are familiar with Google Summer of Code? Okay, most of us. This is a program where Google essentially gives money to students to work on the summer on open source projects. And we had 15 students participate in our program this year. They gave 7 different proposals for work, and we got 2 slots. We were able to pay for 2 of them. And the 2 slots that we got were these 2 here. Somebody adding erasure coding to our durability models, which was super useful. And then Wireshark, a true Wireshark plugin for Ceph that allows you to debug the wireline protocols, which is really, really neat. So that was Google Summer of Code. And then I think, I did have one more thing. We've been doing weekly performance stand-ups, which is this is something that just got started about a month ago, maybe a month and a half ago. So weekly, we're doing meetings about Ceph performance, and they're open for anybody to join and talk about the work that they're doing on Ceph to improve its performance. So check out the URL there. It's about 15 or 20 people in attendance of each of these meetings. So if you are concerned about Ceph performance, as we all are, and are looking for ways to tune it and tweak it, these are the meetings to join. So that's it for me. By way of intro, again, welcome to Ceph Day. Thank you for coming, and we're really excited to have you here.